Okay, so this is 3.2. This is day, I think it's 5. Anyway, this is solving quadratic equations. This should all be review because you did this last year. So when we're doing solving quadratics, when we talk about solving quadratics, we're really looking for the x-intercept. Where does that graph cross the x-axis? Okay? So sometimes they use the word solution, sometimes roots, sometimes zeros, sometimes x-intercept. It doesn't matter. It all means the same thing. So our generic form of a quadratic function, which you already know, is f of x, or remember you could have y, equals ax squared plus bx plus c. Now I'm sorry when I made these that the lines didn't come out. I don't really understand that, but whatever. So you have basically three different situations you can have when you graph a quadratic. Now these could also be upside down quadratics. I just made them all right side up for whatever reason. So this one, if you notice, it crosses the x-axis twice, which is not surprising based on it's a quadratic, x squared. I should expect 2 answers. So this one has 2 real solutions because it actually does cross the x-axis. This next one, notice the parabola is tangent to the x-axis. So this is only one real solution. Technically, it's a double root. If you were factoring and you ended up with x minus 3 equals 0, so you're like, oh, x equals 3 or x equals 3. That's the same root twice. So that's what I mean by a double root. So those are tangent to the x-axis all the time if you have a double root. And then you have one that's well above the x-axis, and this is where you have two imaginary roots because it doesn't cross the x-axis at all. So those are imaginary. So we're going to use these, well, we're only going to use 3 of them. To find the solutions or the roots or the zeros for a quadratic function. And we're going to use our calculator. I'm going to try to step you through that with some awesome pictures I just took. We're going to factor, and we're going to use the quadratic formula. If you want to do the completing the square, you can. That's in your book, but I'm not going to talk about it. So, using our calculator. So the first thing you have to do is you have to put this equation into y equals. All right, you all know how to do that. And if you look at this first picture, which is an awesome picture, here's my y equals up here on the top, which is kind of cut off. All right, so once you put that in and hit graph, which is this button, which I cut off, you get this awesome picture. Now, if your screen is messed up or whatever, right here in the middle, let's see if I can get you to see that a little better. Right here in the middle is the zoom. Okay, if you go zoom, choice number 6 is standard, and that would make it 10 by 10. Each of these little marks on my graph, 1, 2, 3, 4, those are all ones. So those are my, yeah, I can count by ones. So I'm looking for where does it cross the x-axis. Now, I picked one that purposely crossed at an integer, or 2 integers, so you can easily tell if you're correct or not. But it won't always be that way, so even if you try to use your table, it may not work, because if my answer is a decimal, it still may not work. So I need to be able to do this, and this is how you calculate. So the first thing you do is, once you've graphed it, then you go to second calc. So you see the calc up above trace, so you do second calc, and this is the menu that pops up. You want to choose number 2, 0. Okay, you're looking for the 0. So once you do that, you get this screen, and it asks you for the left bound. Okay, the left bound is left of your root. Now I took this picture after I already did this question. So your left bound, if you imagine this is the x value for your root, you want to be to the left of that, so somewhere down here in the negative zone. Okay, so you have to move your cursor, which is sitting at the answer right now, only because I did this right after class. So you move your cursor so it's below the x-axis, and then hit enter. And once you hit enter, it'll ask you for a right bound. Well, if this is my x, then I need something over here, and I use my right arrow to get me to that side. And I want to make sure that my value is positive for y. So then I hit enter. And then the next one asks me for a guess. So you can see up here your left and right bound things. And then so you can then pick something in between there. You can just hit enter again, or you can try to move the cursor closer. It doesn't really matter as long as the cursor is within that range. And then it'll spit out the answer magically. And here's my answer, x equals 7. Okay, and I can repeat that for the other things. The other answer is -1. But again, it's only an integer because I made it that way. Most of the time you're going to have things that are decimals. Okay, so now factoring. Notice I have the same equation for factoring. And some of you are good at factoring and some of you are not that great at factoring. So you don't have to use factoring. So I'm just going to do one just to remind you. So if this equals 0 again, because remember I'm looking for, what is going on? It equals 0. So why is it making, oh, turn that off. It equals 0. Sorry, it equals 0. Let me see if I can make a regular 0. There we go, my messy 0. I have to factor this. So this is where you do your 2 sets of parentheses, right? And so you have x squared, and what makes x squared? You're like, oh, just x and x. So that's here. The last term is negative, so I know the 2 signs have to be opposite, because a positive times a negative is the only way to get a negative. So I just randomly put positive and negative. And then I look for factors of this last term, which is 7. 7 is prime, so the only 2 numbers that multiply to give me 7 are 1 and 7. So now I just have to decide which of those is positive and which of those is negative. Well, since the 6 in the middle is negative, I'm going to make the 7 be the negative number, so it turns out correctly. So that means x plus 1 equals 0, or x minus 7 equals 0. Subtract 1, so x equals -1, or add 7, x equals +7, which is no surprise because that's what the graph showed. Okay? Great. So if you want to practice some of those, I think you have that option. What I really want to focus on is the quadratic formula, because until this year, you've always been given the quadratic formula. And now you're not going to be given the quadratic formula. You're going to have to memorize it. So your friends in class today had a little trouble. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Remember, the general form of a quadratic is ax squared plus bx, this is the a, b, and c, plus c. Now this, you can sing Pop Goes the Weasel to it. X equals -b plus or minus the square root b squared minus 4ac all over 2a. So the Pop Goes the Weasel works with that, so you can practice that. But if you don't know this formula, you need to spend some time memorizing it, because you're going to use it now, you're going to use it in January, so figure out a way to memorize it. And don't cheat by writing it on your hand, as one person in class said today. Okay, so now let's practice this. We already know what the answers are supposed to be, so it's no surprise. So in this quadratic equation, a is the coefficient in front, which is a 1. B is the coefficient for x, which is -6. And c is the number that stands alone, which is -7. Now I know I just wrote the formula over there, but because I'm practicing it, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so there you go. I plugged my numbers in. Now be careful. X equals -6 plus or minus the square root of. At this point, I would encourage you to square b in your head. You know b squared is always positive, because a positive times a positive is positive, a negative times a negative is a positive, so it's always positive. So this is going to be 36 minus 4 times 1 times -7 all over 2 times 1. And so then that becomes 6 plus or minus the square root of. The inside here, this mess on the inside, the radicand, as we call it, You can type that into your calculator, 36 minus 4 times negative 7, and I believe you end up with 64 all over 2. So then this becomes 6 plus 8, which is the square root of 64, all over 2, or 6 minus 8 all over 2. 6 plus 8 is 14. 14 divided by 2 is 7. Ooh, surprise, surprise. 6 minus 8 is negative 2. Divided by 2 is negative 1. So x equals 7 or negative 1, which is what we got when we factored it, which is what we got when we graphed it. So that should not be a surprise. All right, so we're just going to do some quadratic formula fun problems here. Okay, so here's the next one. A equals 1, B equals negative 3, C equals 5. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so that's going to be negative 3. I'm just going to go ahead and call that positive 3, plus or minus the square root of negative 3 squared is 9, minus 4 times 1 times 5, all over 2 times 1, which is 2. So now that ends up giving me 3 plus or minus the square root of negative 11 all over 2. And you're like, oh, yay, an imaginary answer. So it's just 11. So this is just 3 plus or minus I radical 11 all over 2. But remember, probably should write that in a plus bi form. So that becomes 3 over 2 plus or minus radical 11 over 2I. All right, I'm going to quit because I'm getting kind of long and the bell's going to ring. So if you have any questions, let me know. Okay, try the last one on your own, and I'll see